Welcome to today's Explainer. We're embarking on a pretty fascinating journey to completely evolve the way you write code. We're finally moving away from that repetitive, tedious scripting, and we're stepping right into the powerful world of smarter, fully automated Python data structures and loops. Okay? Let's dive into this.
Picture this scenario. You're building an application, and you're hit with a super practical question. How do you actually store the names of 82 or even 1,000 separate students? If you only know the absolute basics of variables, you might literally sit there and manually type out student 1, student 2, student 3, all the way to 1,000. It's a terrifying, painful, manual coding problem that scales incredibly poorly. I mean, it would take forever. There has to be a better way, right?
And there absolutely is. Think about the contrast here. The old way is an absolute nightmare of single variables. Every time a new student joins the class, you're forced to hard code a brand new variable into your system. But the elegant, time-saving solution? A Python list. You just create one single variable called all_students, pop open your square brackets, and neatly pack all your data, like Junaid, Zulfikar, and Asim, right inside. Here's our agenda for today. First, the multiple data problem. Second, organizing with Python lists. Third, automating with for loops. Fourth, tuples and sets explained. And finally, smarter storage with dictionaries. Let's get to it. Sections 1 and 2, the multiple data problem and organizing with Python lists. Think about handing out a biscuit. A standard variable is kind of like handing someone one single biscuit. Once they take it, your hands are completely empty. If you've got dozens of guests, handing them out one by one is just highly inefficient. A Python list, on the other hand, is an entire tray of biscuits. It's a structured container that can hold one item or 100 items, keeping them perfectly organized so you can carry and present the whole shebang at once. But here is where Python kind of throws a curveball at new developers. When you want to pull a specific biscuit off that tray, you have to know its position. And in programming, we actually don't start counting at 1. We start at 0. So the crucial concept here is understanding the index number. This is simply the precise position of an element within a list, always starting from 0. If you want the first name in your list, you ask Python for index 0. The third name, that's going to be index 2. And this system is incredibly flexible. You can use built-in functions like .append to throw a brand new string, or even an integer like the number 90 right onto the end of your tray. Or you can use .remove to instantly delete a specific item, like a student named Daniel, from your list. Moving right along to Section 3, automating with for loops. Let's say you've got a slightly quirky, real-world task list. You need to write an email to your boss explaining that you're running late, generate an AI birthday poem for your friend Tommy, and write a 300-word review of the movie Arrival. If you do this manually, you've got to feed each prompt to your AI individually, one by one. It's incredibly tedious. We need a mechanism to tell Python, hey, take this entire list of tasks and just execute them automatically, one after the other. And this is exactly where the invisible loop process steps in to save the day. A for loop does 3 simple things. First, it iteratively picks up the very first item in your list at index 0. Second, it runs the code block you've written, essentially hydrating your AI prompt with that specific task. And third, it loops back and repeats the exact same process for the next item and the next until the list is completely empty. But, and this is a big but, you've got to pay close attention to this syntax rule. To tell Python exactly which code to repeat, you must use an indentation block. This is the spaced section, usually 4 spaces or a tab, right beneath your for loop statement. If you forget these spaces or misalign them, Python literally won't know what belongs inside the loop and your entire automation is going to break instantly. Structure really matters here.
Let's put this into practice. Imagine an ice cream shop with 4 flavors: vanilla, chocolate, strawberry, and mint chocolate chip. You can run a for loop that picks up each flavor, passes it to an AI to generate a catchy promotional marketing description, and then brilliantly uses that .append function we learned about to save those newly generated descriptions into a brand new empty list. With just a few lines of code, you've built an entire automated marketing pipeline. How cool is that?
Section 4, tuples and sets explained. So let's talk about tuples and sets real quick. Tuples use round brackets, and their absolute superpower is that they are locked down tight. Once you create a tuple, nobody can accidentally update, append, or remove its data. It's perfect for protecting sensitive system configurations.
Then we have sets, which use curly braces. Sets are amazing because they automatically filter out duplicates. Imagine having a massive database of 500,000 students, and you just want a clean list of the unique courses they're taking. A set will instantly strip away hundreds of thousands of duplicate entries, leaving you with exactly what you need.
Which brings us to Section 5, Smarter Storage with Dictionaries.
Okay, prepare for a major aha moment here. The fatal flaw of a list is that its locators are entirely invisible. If I hand you a list of student data, index 0 might be a name, index 1 could be the father's name, and index 2 might be an age. But how would you know just by looking at the raw data? You wouldn't. If your structure has 500 columns, keeping track of blind numbers is practically impossible. A dictionary completely solves this by replacing those blind invisible numbers with explicit named keys.
We literally just swapped the square brackets of a list for the curly brackets of a dictionary. Instead of asking for the data at index 0, you explicitly pair custom keys directly with their values. You tell Python, hey, the name is Qasim and the education is MS. All the guesswork is totally eliminated because your data structure is now highly readable, beautifully organized, and incredibly explicit. So, I want to leave you with this final provocative question. You now possess the core building blocks of efficiency. You've got lists to hold massive amounts of data, for loops to tirelessly automate actions across that data, and dictionaries to organize complex attributes flawlessly. What happens when you combine all three of these powerful tools? You unlock the ability to build fully automated, intelligent data pipelines capable of processing the real world. The evolution of your coding efficiency starts right here. Keep building.